Hey, what's going on, guys? Xianqi here. I just probably lost count of how many times did I try to give up this project on making stockfish that plain CNC basically. So altering the stockfish source code to teach it to play actually the most for Chinese chess. And yeah, yesterday I've spent the entire day tinkering with the code, and I've been trying different approaches, and some of those has been already demonstrated in the previous videos within this series. And again, I swear I felt that I kind of tried anything I could, and whatever I tried did really suck, to be honest. Until yesterday in the evening, some sort of, I was absolutely exhausted, and then some sort of a thought has actually come into my mind. And I've just thought that why actually I'm trying to write the code along with the standard Stockfish's features when I can actually try to reuse the existing code. And again, I couldn't do this before because I wasn't really deep enough into the code base. But again, after spending several hours tinkering with the code, I feel like I've just started understanding it a little bit better. And I even started seeing some benefits in how things done in Stockfish. It's totally different compared to what I'm usually doing in my chess engines, but nevertheless, so this is worth trying. So again, for those of you who is not aware what the hell is going on your screen now, so I'm trying to make a version of Stockfish that would be available to play Chinese chess variant. And the very first thing to consider is the board needs to be not 64 squares but 90 squares. This is the one consideration. Another current consideration that we actually need to have. I was just making a test, so I was making perf test comparison. So how fast the mode generator is generating the moves in Fairy Stockfish, which is also capable, which is a fork of Stockfish for multiple variants, and also can play Chinese chess. Also, I've been testing Chameleon Chess Engine, which is written by Wilbert Lee and derived from Stockfish 7, which is also an engine to play Chinese chess. And also, I've been testing my engine, Wukong CNC, which is written in JavaScript. It's a very simple engine. But surprisingly, my JavaScript engine has even a little bit faster mode generator compared to Chameleon one. And slightly slower than the Fairy Stockfish's one. So it's really weird that the array-based mode generator written in JavaScript, which is around 5 times slower compared to C++, actually performs around the same. So if you're interested to see those kind of stuff, you just check out this playlist on Chess Programming channel, Xiangqi Stockfish, and there would be the video, the third or the second, I don't remember, where I'm just showing how I'm running this perf test in 3 different versions, and you just see it with your own eyes to believe what I say, basically. So the idea that actually naturally came into my mind was to drop bitboards completely and try to make an array-based mode generator. And this might sound weird, but assuming that nowadays evaluation is getting replaced by efficiently updatable neural networks, also known as NNUE. That's definitely the future development of the entire evaluation, and mostly one of the major reasons of using bitboards apart from speed. But again, speed is only for 8 to 8 square boards when we have a single unsigned long integer with a 64-bit long variable, right? So 64 bits is enough to hold the international Western chessboard, but it's not enough to hold Chinese chessboard. So for Chinese chessboard, we need 128 bitboards. And that's not already that fast because it doesn't really fit the single takt of the processor with the 64-bit architecture rule. So yeah, it's not an option really. So the reason. The first reason is because it should be faster, and I've been consulting from guys from Talk Chess, and it seems to be like a reasonable change. So I think they would be laughing at my idea, but surprisingly it didn't happen. So it seems to be kind of interesting thing to make this to make this array-based board representation and actually generate most only relying on the board array, nothing much but the board array. So this is on the one hand, and on the other hand, bitboards are actually used, were really heavily used by the evaluation before the efficiently updatable neural networks appeared. So things like getting the pawn structure, semi-open files, piece mobility, etc. So really lots of handcrafted evaluation terms were really relying on the bitboard structure. But as far as I'm not really going to be using all of that, and I just really want to have a very simple mode generator. So that's the reason why I actually want to drop the bitboards from Stockfish completely. And I was thinking with this stuff for a couple of days already, and I felt like completely exhausted and done, and like nothing works. But again, like after the recent observations of the source code, I think that I have an idea of how one can do it. So I realized that actually Stockfish obviously does keep track of the board array, but that's the 64-bit, the 64 squares array. And even if we're talking about international Western chess, to make array-based mode generator, we need more than 64 squares to easily detect the off-board squares in the fast way. So there are multiple ways how that can be done, like hexadecimal 88 system with 128 squares, 10 multiplied by 12 square system. And for CNC in particular, I'm using 11 multiplied by 14 because we have 9 files and 10 ranks, and respectively we need a board 11 by 14 to take care of the off-board squares, so with pieces jumping from one rank to another. And all the trick is, so the very first step, before we're talking about the different variant, before we're talking about the mode generation for pieces, before all of this stuff, the very first, the most essential thing to consider is actually to increase the board array size. Because in Stockfish, okay, I just probably already, I will fork the code countless number of times. I've been forking this, so I will do this one more time. And so just to show you what I mean, I would start the work, and would be covering this stuff along the way. So I didn't yet try what I actually want to try, and I really wanted to share with you guys this sort of an idea. So at this moment in particular, I'm not sure whether it works or not, but at very least it's yet another kind of like attempt to step into the Stockfish's code base. Yet another attempt, right? And even if it sucks, even if this idea doesn't work anyway, this might be interesting even for those who's not interested in Chinese chess, because there won't be anything related to Chinese chess directly in this video, but rather tinkering with the Stockfish's source code. So if you want to know more, a little bit more about some specific parts of especially of the position H and position CPP files, which are responsible for representing the board position, so board representation literally. So in that case, feel free to follow. You might find something interesting, because again, like, it's not really that clear of where to get those knowledge, so only from the source code basically. Okay, and before that, no, so actually I'm thinking, I was just thinking about disabling an NUE, but I don't really need to care about this, at least for now. So let's see what they currently do for what they suggest for build. Okay, portable compile, so maybe I should consider this one. Yeah, I think this is the easiest. Well, actually, I just want to alter this a little bit. So I want to say the compiler equals to GCC. Yeah, I would download an NUE, unfortunately, but it doesn't matter really. And I'm just wondering, I've never been watching if there are any how actually to build this for debugging purposes. I didn't really debug yes, debug no, probably this debug yes. So I could have run the assertions, well, like I think. Not really sure, but yeah, this should be debug yes. Okay, and is there any way to disable the NNUE? I'm wondering. So is there any way to disable NNUE default net? Probably they don't even allow this anymore. I'm not sure what exactly has changed from Stockfish 12 to Stockfish 13, the current version, and the current one I'm now forking is already the latest development version, I believe. Okay, so now we should be able to Stockfish. Yeah, it's alive. So we have the board. Okay, so this is what we're gonna be tinkering with, this little board. And by the way, it relies on the board array. The matter of print the board relies on the array, not on the bitboards, which is good. Okay, so one more thing. So I want to run Stockfish after a build. Okay, and I also want to compile for debug. So debug equals to yes, I guess. Okay, was it really yes? Debug. Okay, yes, no, enable, disable debug mode. Oh, so this is done with D&D debug. Or hold on a sec, maybe just I'm not sure what this is all about, the assertions. Yeah, it's probably just to work with the debugger itself, not the Stockfish related asserts. Or hold on a sec, if I just explicitly say that debug equals to yes. Okay, and I just never tried this before, to be honest. This doesn't really seem to be. Just can't see this D&D debug flag. Okay, configuration, so debug is equal to yes. Okay, and if here I say make it no, does it? Yeah, it does change like this as well. Optimize, sanitize. I'm just not sure whether the debug actually enables the asserts or not. So if we just say go birthed 5, let's go birthed 6. Okay, so this is within the debug mode, and this should be faster. Go birthed 6. Well, the speed seems to be around the same. Well, okay, so probably, yeah, as far as just not sure if this is about the asserts or not. Need to check that out one day. I don't know. Okay, just really wondering. Maybe it's within the types. So if there is something about the debug. Disable debugging mode, always use this for release. When compiling with provided make file, configuration is automatic as a target. Make help when make file is not used. Some switches need to be set manually. Okay. By the way, yeah, let's have a look. Make help. Is this the same? Yeah, it's the same stuff, right? Simple example: supported compilers, supported args, supported targets, help, download net, faster build. Oh, faster build with profile guided optimizations. Well, this might be interesting, yeah, as well for development. But again, like, yeah, it's not really something that I really wanted to share with you guys, so it doesn't really matter that much. So yeah, we'll stick to this build command basically. Okay, so let's go to position H, and here we have the position class holding stores information regarding the board representation, pieces, sites, and move, and all this stuff. So it's really lots of stuff here. But the actual array that stores, okay, so apart from bitboards that I used for node generation and detecting the attacks, so the actual position can always be retrieved from this board array, and this is really awesome. So if I just to give you an idea, so there is a method here called piece on, and you see it just returns board the board array indexed by the current square. And if we have a look at position CPP, and here is the code that actually prints the board to screen. Okay, and what it does, so it just loops over files, right? And it actually calls this convert piece to char from what is returned by position.piece on, and also just make the square. So it's really lots of things to alter here, and probably I don't really think this would be within the scope of this video, but anyway. So the idea is very simple, that to get the piece from the board using this piece on, and it just relies on the board array. It doesn't actually do anything with bitboards to retrieve. So anyway, every time that when we want to get something back from the board, just say where the piece stands, we're not really probing bitboards in this case, which is really awesome, by the way. Yeah, because when I did my bitboard engine for international Western chess, I probably at first didn't even have this sort of an array. I don't remember if I did add this later on, to be honest. But initially, I didn't really have that. For me, writing a function to print the board was a real pain, because I really needed to probe the bitboards themselves. It's much easier here. So another essential function is the function to set the position from the FEN string. So for those of you who's not aware of what the FEN is, let me just very quickly show you. So just grab this from one of my engines and go to my JavaScript engine ukun.js, which is, by the way, available to play online. It's not strong, but anyway. And I just want to grab a couple of FENs. So yeah, let's take this one. So just copy this, and then going back to Stockfish, and we can say like, so this is the UCI command, position FEN, and then print the board. So like the board position has changed. Okay, so this is another. So now I'd like to introduce another function that actually deals with this board array, and this is the function to set the FEN. It's called position FEN just returns. No, we need another one. Position set, but not this one. Instead we do need this one. So the core function here, so when the piece, okay, hold on a sec, bitboards, Oh, it's say set state. I'm sorry, it's not that. That should be set fen. Okay, this is it. Yeah, this is it. So here, no, hold on a sec. No, it's okay. It's okay. So put piece equals put piece. Oh my god, I swear I saw that. No, this one returns fen representation of the position. Okay. So we need position set. There are just two instances of position set. Oh, okay, this is it. Yeah, there are just two instances. So here is the right one. So yeah, this is it. So put piece. This is what piece we need to put, and this is the square where we need to put a piece. So yeah, they just I guess this converts the, or this should be converting ASCII character to the internal piece code, and then we just put in it on the board. So now the next thing, so we had the piece on function, piece on, to get actually the what is there on the board array. Now let's have a look at put piece. So that's the second most essential kind of like stuff. So put piece, just let's search for a put piece. I don't promise to. Oh, okay. Here it is actually. Yeah. So here is the put piece. Here is the put piece. So the very first thing to do, you know, guys, just know this, that we're setting the piece to the specific board position, and then everything that goes to big boards, and also yeah, so they do initialize the p-square tables. The way it's done in Stockfish is, yeah, it's, for me personally, it's a little bit not really clear exactly why that is needed. But what I actually need, so I actually only need this board array. So the very first thing I need, I just want to disable all the stuff that regards with bitboards and anything else but bitboards, and it actually should stop generating the moves, but at the same time not giving any segmentation faults as it usually does. So that's kind of the way. Also, we can remove the piece. So what I want to do, I want to command all the code that regards to bitboards and anything else but working with this board array, because when I would be changing the size of this board array, I really need to make sure that if any errors arise in that, it's only the matter of having run index in the board array itself or something that is something that doesn't really rely on bitboards. So just to make sure that that's not a bitboard error, just to narrow the scope of the possible potential issues. Okay, guys. So, well, actually, similar stuff should be done. Yeah, like in this case for remove piece, etc. So, yeah, we don't even not need it because it's overwritten by the capturing one. That's true. So. Yeah, later, well, as far as we're not moving any pieces, this should be enough. And this is actually what I wanted to try, guys. So I have no idea, is this still gonna be working, to be honest? So I probably should still see the board because we do put pieces on a board. But the bitboards shouldn't be any longer kind of like being affected by setting a specific fen. And again, like then I would also need to disable the bitboard update, the update of the bitboards here. So at very least it should give a speed up because we don't do tons of job, tons of work. But anyway, yeah. So we'll see how it goes. It might just give a segmentation fault at the moment, so I don't promise anything really. So this is just a tinkering, but I just really wanted to share this next approach, next idea I'm trying. Okay, so we did we did manage to compile this stuff, which is already good. So let's print the board. So it seems like the board is still available, right? And let's try position FEN and paste the position and print the board again. And still this is available because we do initialize the board array here within the put piece. But now if I try to make, say, perf, say go perf like 1, well, if no segmentation fault, this might be just a segmentation fault, but it actually shouldn't be now generating any moves. It should be just return 0 or something. Well, actually it does generate. Okay, so it seems like it generated moves for pawns. But the victory here, guys, and I'm so excited, I'm so happy to see that. You see, like, no more slider pieces, leaper pieces moves are generated. So what are these? A1 to B1, A1 to A2. Hold on a sec. A1, hold on a sec. A1 to B1, A1 to B2. Well, this is a little bit strange. Oh no, this is not strange. This is not strange because I didn't yet disable the rest of stuff. So, well, but anyway, yeah, probably it still does generate moves for some. Yeah, actually generates for rook. Okay, so another stuff to consider. So removing piece. So also I want to remove this code. So I remove piece. And also when I move the piece, I want to, so again, like anything that relates to bitboards, so piece, board piece. Okay, then we do erase the piece, no piece, board to piece from, and I don't want to do anything with the piece square tables. Okay, this feels a little bit strange. It feels like the piece square tables somehow correlate with the piece list. It might sound like a crazy idea, but I don't even know. Well, okay, it's not the scope or the current stuff anyway. So put piece, remove piece, and move piece. Yeah, this 3 seems to be like the most essential. Oh, okay, guys, let's try to compile and run again. So, okay, I'm sorry, so unused variable piece. Okay, so this oh, actually, yeah, hold on a sec. It's unused because piece count, make piece color. So yeah, no, this regards to piece lists somehow. I believe somehow this regards to piece lists. So, or no, hold on a sec. Well, actually here, hold on a sec, we don't need anything at all. We actually, yeah, hold on a sec, we just can implement everything, because yeah, this would still get overwritten, right? So even though it should be working like so, I just really want, yeah, so now we shouldn't be having, okay, hold on a sec, remove piece, unused parameter s. Okay, now we have this one being unused. Just want to get rid of the wording basically. So say board s. Now this would be used. It does nothing, but hold on a sec. What's wrong? Statement has no effect. Well, okay, so just to give some sort of a placeholder to this stuff, yeah, just it's totally pointless, but yeah, just to avoid the warnings, I comment out this part. Okay, so maybe now Just don't really want to see those warnings. Okay. So the idea behind these warnings is that the compiler actually tells you that you have a variable that you're not using, or or the way how you use the variable doesn't make sense. So yeah, compilers are really smart nowadays. So at the moment, I really hope that actually move generator should not be producing any moves. That might sound really weird, but that's exactly what I'm trying to achieve, believe it or not. So I'm just trying to make move generator to prevent move generator from generating the moves, because in that case I would be able to, okay, no warnings, and we got the compile perfect. So let's have a look. Okay, and so go perfed. By the way, it should be whatever. No, it still just generates some. Or hold on a sec, how on earth is that possible? A1, B1, A1, A2, A1, B2. What the heck is this? It's a little bit strange. So A1 is a rook. B1, A1, A2, A1, B2. So he goes with the rook here. Well, that's because no blockers and things like that. That's fine. I'm just not really clear why still can I try generating the moves. A1, G1, but no A1, D1 actually. It's a little bit strange. Well, anyway, so another experiment. So hope. Well, at very least, I'm already happy that I don't have yet a segmentation fault. So if I just try to search, so let's say go depth 10. Yeah, and we do search. We search a bullshit now, but we do make a search. So search still works. The move's horribly totally wrong, but we still have a working engine, and that's really awesome. Okay, and this is it. Okay, guys. So I think this is it for this video, and I really think that this experiment might be treated as a successful one. By the way, well, I've just realized that this sort of an idea. Well, I feel like this is my own, but actually it's not my own. And I had a consultation from Fabian Fichter. Hope now I pronounced his name correctly, so he kindly pointed me out that I was actually pronouncing his name wrong. Fabian Fichter, the author of Xiangqi Stockfish. Yeah. So if we just go here, and no, sorry, what have I done? I had a discussion with him. So I was asking regarding the way to go, and here is what he suggested. So if you're ready to burn bridges, removing everything related to position handling, move generation, and evaluation, and then rewriting a position class with the same interface, search uses plenty methods of position, this currently should work and might be the fastest theoretically. But he says, like, I personally perhaps would not dare the first approach. And you know, like, what I answer is the first option seems to more fit my style, but despite the fact it more fits my style, it sucks because I'm too bad programmer actually to come up with that, even to try. And even if the guy like Fabian Fichter actually says that he wouldn't dare the first approach, and just to give an idea that he has created really lots of variants in his Xiangqi Stockfish and developing this for quite a few years already, and yeah. So even if he doesn't dare, then for a noob like me, it's definitely not the way. But here is an interesting thing. So it says, like, personally perhaps would not dare the first approach because one can easily get lost. That's what happened to me yesterday. I guess I would first introduce the new data structure redundantly to the existing ones, and then step by step replace all usage of bitboards until none are left, and then remove them entirely. This is an advantage of always having a fully functional engine and being able to easily check if changes is breaking anything. So, well, a slight difference compared to what am I doing is actually I didn't yet introduce the new data structures, and it feels like there is actually no need to introduce the new data structures like I thought before. So it seems to be literally enough to work with the current existing board array because it's bundled there, so everything is in there. So I just only need to alter the size of the board as the very first step, and then just try to alter the parser. Well, I will probably even, well, I will need to slightly change that, but well, anyway. And then what I did today is step by step replace all usage of bitboards. Well, definitely what I've removed at this moment is not all the usage of bitboards, because it really is the bitboards I used within the mode generator as well. But anyway, it's really good that still I didn't break something. So this is it. The advantage always having a fully functional engine and being able to easily check if a change breaks anything. So Fabian, if you're watching this video, I think he doesn't watch my videos, but it seems like he does. Yeah, he told me like his actual name, how to say properly. So that's why I think that he actually does actually watch my videos. So if you're watching this video, I really want to thank you one more time for this immense help you gave me. So it's really appreciated, and without your help I won't probably be where I am now. Not sure if I'm going anywhere still, but at very least I feel like I can take at least something, start sticking to something, because otherwise it's really hard to proceed. Well, okay guys, so this is it from my side. Thanks for watching. In the next video I will dare to try to actually start changing the board size of the board array. So prepare for never-ending compile errors and segmentation faults are about to follow in the next video. But at very least I'll try to start it in the live mode like this one, and then we'll see if I would be smart enough to proceed with this mode. I really doubt about that, but at very least hopefully I would be able to keep some updates regarding this work. And again, like, I still can't guarantee that something would work out of this idea, but anyway, this sort of steps I'm making, they actually do help to get used to Stockfish's code base, and this is interesting. This is really fun on its own, to be honest. So it's seeing like how the top engine is written is really fun. Well, okay guys, so this is it from my side. Thanks for watching. Until the next time, and take care.